Yeah, sure. Uh, Thank you, Manshu. So we just thought to utilize this time effectively, right? Just to have, like, just to check with everyone, right? Uh, how they are going with the learning and if they are facing any challenges, right? So that is the purpose of this call. So let me share my screen. All right. So here we go. So let me just give you a little background, right? So for example, you can search something on ChatGPT, right? For example, if I go in a mode or any large language model, right? So if I search something, what is RAC? So you see here, these models are pretty much very well trained, whatever data they have in the backend, right? And due to that reason, it is able to understand very well, right? What is RAC, right? If I ask another question, what is Hugging Face? Okay, so it pretty much understands all those things. That is the reason it is able to answer these things, right? Maybe like how it is finding these things because it contains in the search memory what all things I'm searching in. Based on that, it sets some pre-context, and due to that reason, it is able to answer very correctly. But if I'll ask very some weird question, right, which it is not aware about, right? Let's see what it says if I ask to this guy, what is my name? You see what is saying? I don't know your name. I am AI assistant. I don't have access to your personal information unless you explicitly tell me what is with our conversation, right? So that means AI can only answer behind the scene what is happening, right? It is just nothing but a large language model which is sitting behind the scene. And what happens once you ask something, it goes to the model, queries to that particular input, and it finds the most matching record and it shows on the top. Whatever you see on the top, it has a lot of similar search in the background, but it shows you the one which is the most matching record, right? Sometimes what happens, right? This example you see here, I asked, what is my name? He don't know. Why? Because he's not trained on answering this kind of question. But if I would have given another prompt to him, this particular LLM, my name is blah blah, I live in here. Then if I'll ask question, right, it will be able to answer that particular thing. So the same is the thing, right, which comes once you're going to integrate Gen AI with your any domain specific data, the same kind of problem you will find. it will not be able to understand what you are asking for from your data point of view, right? It understands a lot of things, but it does not understand specific to your domain. So the Gen AI is a technology which helps you to train the base models based on your contextual data. So that is known as a context. If I give certain context to this guy, and if I ask, uh, what is my name, then it will be able to answer. Let's see how it behaves, right? Now I gave certain context. Whatever I'm pinging it, it is recording the chain of conversation into its memory. So that means these things are whatever I have asked, it will be able to correlate, right? So if I ask where do I live, because I have gave certain context, so it is able to answer whatever question I am asking related to that, right? The first thing which it was not able to answer, what is my name? Let me ask the same question again. Your name is Pramendra Singh, right? So that means it understood the context, whatever I provided to this particular LLM in the background. And once it understood the context, if any time I log in by this ID, this my Gmail ID to this LLM, it will record these things into the memory and it will be able to answer these questions, right? So let's understand this problem statement, right? This problem statement will also come once you will try to integrate these things with your organizational data. You will ask, how many employees are there into my organization? It will not be able to answer. You will ask, you have certain, take an example, certain documents stored, right? You will ask for this particular complaint number. What was the concern of a customer, right? It will not be able to understand until and unless you will not train that model from your organization data to answer those kind of questions. So in order to like overcome with these kind of problems, there is a pattern introduced with Gen AI that is known as a RAG. RAG is nothing but retrieval augment generation, right? So we are going to talk about that and just set the context. Whatever I told at this moment, this is pretty much the fundamental which it is going to be used in the background. Okay. So before I go there, right, let me start with the uh, I hope the problem statement is clear, right? Then we'll go to the next step.
Yeah, I'll just repeat like what I understand with this. Let's say you have asked this question, what is my name? So the LLM doesn't know your name because it doesn't have the context or access to your personal information or your yeah. So like it doesn't know your name. So you have given your name in the chat. So you have given in the chat state, you have given it the context of your name and your city. Then it has this context of within this chat, it has this context of that your name and your country that you live in. Now, if you ask the question again, because of the context that you have provided, it is able to answer this question that your name is this. So, in the same manner, because this chat, when you close this tab, this chat will be deleted, and maybe it is the chat will be saved, but it is not. It is just a reference of what we are trying to do with the LLMs, but not with the chat, but with a proper implementation of how we can do it in an organizational level. So that's why we use this RAG implementation of LLMs so that we can provide the context to the large language model to answer the specific questions for our use case.
Yeah,
Uh,
exactly, Himanshu. That's
yeah.
correct.
Okay.
So
S-
you have pretty pretty good understanding on this particular concept. So let's talk on the next points, right? Take an example. We are learning here, right? We have done enough Python things, right? So that means now there is a next level. Will not be working whole life on Jupyter Notebook. Okay. So Jupyter Notebook, sometimes I mean at certain point of time you'll have to go away from that. Am I sharing my screen?
Yes, sir.
Okay, great. I just wanted to check. At certain point of time, you will have to stop using that Jupyter Notebook, and because the reason being, Jupyter Notebook is not utilized in the real-time application programming. When you will deploy something on servers, your Jupyter Notebook will not be your test harness, right? So you can still use Jupyter Notebook as a test harness, but not as a building block of your code, right? You cannot rely on that because there is no way you can load something as a module level, and you can use it, right? So first I'll talk on that, then we'll come on if you have to start on these things, right? What are challenges that you have currently? Then we'll go to the next level. It will not take much time. So take an example. What I follow, I have a GitHub repository. So this Google Colab, right, provides you flexibility to load your private and public repositories both. So that means if you are continuously working on anything, and in case sometimes why I have to use this hybrid combination, I could do this. Your question will come. I could run it on my local machine also, right? But why I'm going this route? I'm saving my code on GitHub repository. First of all, I'm committing my code from local machine here. Let me show you that.
Yeah.
So this is my drive. So here, if I show you certain example, right? If I talk about this repository, which is LLM integration, or there is a RAG design pattern like this one. So what I did, right? I checked in this code from my local machine, the way you do in the organization. I have been pushing this code from local machine to the GitHub repository, right? And I have my this setup on my local machine. I can do the same thing that you do regularly in your office. I can open it, and I can commit the things. I can push the things from my local machine, right? So these are very simple steps. I hope most of you might be aware. If not, you can follow this. This is a very simple steps, right? You can install your Git Bash. You create a GitHub repository, clone it from there. Then once you clone it, you will get the data. You can get the latest of whatever is inside your repository. All those things are possible. I'm not going to cover that into detail because those things are pretty much, if you're interested, you can learn on Google and do all those things, right? I'll be only focusing on how would you modularize your code, and how are we going to reach to the next level where we are not only limited to the Jupyter notebook. We are writing the code which is modular, which is following object-oriented programming, meaning to say your code, if you are using your code more than once, why don't you wrap it under classes, wrap it under function, and trust me, there is everything available whatever you have done in the programming language, right? For example, there are a lot of design pattern which you can implement in Python, and some of them are, for example, the very commonly used pattern is your single design pattern, right? That is also possible. I'm just telling you the block possibility which I have explored so far. I'm not going to cover all those things because this will take a lot more time if I'll go in deep everything, because I'm talking about how to write the modular code and how to leverage it so that you should be pretty much near to the production code, right, that you want to build it. So in order to do that, right, for example, I have this is my like one repository which I have created on my GitHub repository here, and I have cloned on my local machine, and I have flexibility. I can go there, and I can like change the things from my local machine and push the things. It will come here. You see here, there are the commits almost on every day. I was creating one diagram for this RAG architecture. So I pushed these things yesterday. So now the thing is that, right, if you understand what is the code structure, right? So here it is basically your requirements.txt file, which basically tells you how many dependencies you will require. Currently, how we are doing in collab, right? We do pip install. But that is not the proper way. Once it will go on server, there should be one command which should install all your dependencies in one go, right? So whenever you deploy it on server as a API or as a web application, then what we require to do, we will have to provide this script pip install minus our requirements.txt. So what it will do basically, it will download all the dependencies from here, whatever you have mentioned, and it will install to your virtual environment on the server, and it will bundle together, and you can have that particular folder somewhere on your server and invoke it from there. That is how your real word application will be interacting. If you're exposing it as a API, right, that is how your real code will be interacted through outside the word. So I mean, this is a very high level, and I'm just going to tell you, right, before I go further, right, is there any question so far? Yeah, Himanshu.
So, sir, you were basically explaining why we are not using the Jupyter notebook and why we are enforcing this project structure is because Jupyter notebook are meant to run in an isolated environment, but in the production environment, there is a whole project structure that we need to follow, and that's why we are focusing on the implementation part of
Yeah, that's fair. You
yeah,
understood very right. So
right,
Jupyter Notebook is only your ABCD program, right? You cannot go too long. Your Jupyter Notebook, you cannot load programs from one Jupyter Notebook to another Jupyter Notebook, right? All those level of challenges are there. For
mm,
example, if you're working on a bigger project, you have one common method. You are connecting to Oracle database, right?
right,
And you cannot copy paste same code at 10 places. Maintainability will the problem. So you need
maintain,
a
yeah,
solution where you have written your file, related things into one file, single responsibility principle,
yes,
where you are collating all the related things into one file, and where as and when needed you are creating the object of that class if it is a class, or if this is there is no class, you have a direct function that is known as a module in Python, right? So you
right,
can create the object of the class, or you can create the instance of your file, which will serve as the object of that particular file or module. And whatever functions are written into that, you can directly import that into Jupyter Notebook or anywhere. What I'm suggesting here, right? We need to gradually get away from that Jupyter Notebook concept. Still you use Jupyter notebook, but you go with as a test harness. Do not use it as a your regular programming practice. Okay,
right.
are we good here?
Understood, sir.
Should I
Yes,
go? Should I go and show you how we can import this repository over there in Colab?
yes, sir, please.
Okay, great. So you're not doing any duplicate work. Centralize all your logic over here inside this repository, GitHub repository, and have your reusable functions classes written over here. It was just a basic starting. I'll keep continuing enhancing this code to the industry level, where further I will go ahead and add classes, and whenever I'll be invoking, I'll create the instance of those classes. And I'm also thinking how to implement singleton design pattern. All those things will gradually come into picture, but not at this moment. This is the very first phase of the starting and exploring the things. I'm also exploring. I have a great experience on programming language, how to maintain the code, but still, these models is everything is new for everyone, right? LLM. This is also new for me because this is something which is not the code which we have developed. This is something which is developed by the tech companies, and tech companies are what abstraction layer they are having. They are having in the background, right? What functions they have written. You will have to understand those flexibility functions and what those functions are doing basically, right? You'll have to understand their documentation, and you'll have to understand how they expect certain things to be passed from your side. So we'll go gradually to that level. So this was now the second step I'm going to explain. This is my GitHub repository. So currently I was exploring, like you cannot directly, so there are two ways. Okay. So I have tried multiple ways. So the successful way was this way, right? You understand, you have this GitHub repository. Okay. what I did, uh, and I'll explain you right why I did that also. So if I have this program, okay. So how I'm calling this program, this for example, I have a main function, I have this function, right? Generate content, where I'm giving certain prompt. It is connecting to one of the LLM, Google Gamma, and it is finding your input and it is returning back to you. Okay. So what? Uh, take an example. How would you call it from Google Colab? Your code is going to remain over here. You are not going to copy paste the same code on Google Colab, but you should have flexibility to invoke these functions over there, right? So let's see how can we do that. So this is my main business logic, which is sitting over here. So what I did, right? If you go to my repository, so I have one another repository which I am using is that as a playground. If you go to repository here, uh, here there is a first to get some this one. So this is the first one which I created 5 years back, but I'm just using it as a playground. So what this particular repository, the purpose of this repository, another repository, is that I will have all my code Python notebook under this repository, and from this repository, I will be the thing that I need to load. For example, I need to load from my RAG repository something. So I will simply open this notepad, RAG notebook file into my Google Colab, and I will clone my RAG design pattern repository over there. If I say clone, meaning to say your Colab environment temporarily will download all the code into your Colab repository, Colab environment, and from there you can pick your functions, whatever you want to call. Okay, so let's see how can we do that. So here, once you log into Colab, right, then here is an option for GitHub repository, and here you can check in this particular include private repos also. So it will give you flexibility to in open private repository over here, but you will not be able to clone that. Understand there are two things. One is cloning the repository. We need to say your whole file is coming into picture, whole repository is coming into picture. Another thing I'm saying, you are opening one of the Jupyter notebook file from here. There are two different things, right? So let me first clone the repository where I have my core business logic, which is a RAG design pattern. So here is your RAG design pattern, this one. Make sure when you are trying to clone it, right, this particular repository should be public, otherwise it will not allow you to clone it. Okay, so rather I'll go with the this my first Git repository, right, which I was showing here. So here, this is my public repository. I am going to open the same file which I was showing you over here. So this was a file, right, where I was referring. I have kept my notebook over here. So let me open it, then we'll talk on the next steps. So this repository loaded over here. Okay, so I am using this as a playground, and whatever changes I will use to this notebook, I will be able to commit directly to my GitHub repository from Colab itself. I will not have to log in or clone these things on local, paste, and then push it over there. Let's go step by step and understand what are the things are happening in the background. I kept clicked on this files icon, so it will let me know if there is anything changing in the background, right? So if you see here, there are only few files at this moment. Once I will clone this repository, make sure this repository should be public repository. I was exploring, but I so far I could not find the option how to clone private repository. So what I do, right, if I have certain sensitive information to that, I make it public, clone it, do my work, then make it private. So that is how I do it. So currently I made it public. So what I'm going to do, this command is going to clone your this GitHub repository, the path which I was telling here, right? If you go to any repository and if you click here, for example, if you go to here, this option, right? So you will find those information. So here you see this cloning option. So you copy this. This is the same path which GitHub provides you. right? So this is a .git path. So I am using the same over here at this place. I said clone this repository. So what it is doing to do, uh, I'm going to run it. So just see what all things are changing. You see, my whole content got loaded over here in this environment. Even image files, my Python file, everything got over here. But I cannot directly run it from here. In order to run it, I will have to take this Jupyter notebook to invoke this whatever I do have into my main.py file. Okay. So what I'm going to do, currently the folder path is at this level, root level. The GitHub, this collab is at the root level. I'm going to switch my path under this folder so that I can find respective files which I'm looking for. So I did this. It now my path got switched. The command path, right, is got switched to this one. Now I'm going to do this is the same thing which I was talking about, right? So this is important when once you deploy your things on server, you will have to bundle all the requirements into requirement.txt file, your all the dependencies, right? What all libraries you are using. So this file I'm talking about. This file contains what all things I'm using. There are ways where you can also mention the specific version. You can keep double equal to and mention the version number, whatever you are using, right? So for example, this python.env I'm using to read the environment variables because you will read the environment related data, right? What is my secret key? What is other things, right? So those things will come from your environment variable. So in order to do that, there is a OS command, and there you can use it. You can explore it on your own. I'm not going into too much detail. This is transformers, which we'll talk about, for which we have connected over here. So let me take a pause and ask if there are any questions so far.
Sir, just one question regarding as we what I understand what we are trying to do here is we are cloning this GitHub repository into a collab notebook environment. We are trying to yeah, this is what we are trying to do here. My question is why are we doing it? Is it because of the GPU constraints on my local machine? That's why we are trying to do it. So that my code converts into a Jupyter environment, or why are we doing it? Like initially we started the conversation like Jupyter Notebook is for the testing and local environment only, and now after why are we converting this into a Jupyter Notebook?
Yeah, there are two answers to this question. The first thing that you told, that is absolutely correct. uh, you can because of these constraint, right? Your once first of all, where we are going, right? Why how we are going to use LLM as a developers, right? We are just practicing. We cannot go and register a credit card so that they can start charging on our credit card per request basis, right? So we don't want to do that. So in order to, if we would have that flexibility, for example, if your organization has that flexibility, you'll not,
Mhm.
you can run those things from your local machine also. You can come to this your notebook, you can run it from here. It will also give the same output. Why we are going here, the reason being, this particular first of all, it the whenever you load your LLM on your machine, it is going to take a lot of data, dump on your app data file, and it will fill your memory. It is close to sometimes 5 GB, 5 to 10 GB, those kind of model sizes there, right?
Mm.
So
Right.
practically, you cannot do it. You cannot reserve 10 GB of each model practice on your machine. It is not possible flexibly. I mean, technically, everyone does not have that much space. If
Mhm.
you have that space, the second challenge that you will get, you will find whenever these models will keep loading, right? It checks a lot of free space into your RAM, right?
Right.
And that request for close to 15 GB or something like that, right? So there is a huge space that is required into that. So considering those requirements, there is no possible option where you can run your LLM from your local machine. You will get into the problem of having virtual memory full. Those kind of errors you will get if you try to run this code from local.
Yes,
Does
yes,
that
sir.
answer the question? Okay.
So just a follow-up last question to this. So like we are doing, first of all, why we are doing it in this Python modular programming on our this GitHub repository fashion, because of that's why because of because of the like how the projects runs in the project in industry standards. The project doesn't run in the Jupyter notebook. That's why we initially started this with this GitHub repository, and now we are converting back to Jupyter Notebook because of the uh, of the GPU constraints and memory constraints on our local machine. So
That's
that
correct.
we
That
can.
is one option. Another thing is that, right? Like if you run program from your local, okay, you are running one file here, right? You will not understand how your consumers are going to use your program. For
Correct.
example, if you'll run by this way, you will understand what all imports you will have to do on your machine. How would you access a function which you have written in a file from an object, right? So this is all going to help you to visualize those concepts and
Okay.
what all things you will have to do in order to expose anything to the outside world, right? How would you use environment variables? In SIT, you have a different URL. On UAT, you have a different URL. Production will have different URL. You cannot hard code everything, one thing for all, right? You'll have to load the things at the runtime.
Correct.
So this, if you'll practice this way, right, it will give you flexibility to build your system accordingly so that you can feed in any configuration from your collab notebook. It will go and gel up with your code and it will invoke that environment, right? So those, in order to practice these things, we are going in that route so that it should look like you're very close to production code.
Okay.
Is
Thank you.
that a,
Thank you, sir. Yeah.
okay? Good. Anyone else? We'll go till 12. I have enough time. I'm not in a hurry. If anyone wants to ask any question, why we are doing, what is the purpose of this?
I have a question.
Yeah, please.
Yeah. So, yeah, I understand why you are doing this. So, that's not my question. My question is just only this. Normally, I do all those stuff in like the VS Code or the Visual Studio. So, there after that, you know that we have to check out the local branch. Okay. So, when you are cloning it in the Colab, so basically, you are also checking out a local branch, but there is no name of the local branch, right? It's a same concept, or in the next few cells you are going to check out a local branch.
Here I have not explored to that level. Definitely, there will be certain option, but here,
Okay,
if I'll do default cloning, right, it will go to my main branch, whatever
so
I
this
do have in
okay,
GitHub
it's
repository.
directly
Right?
going to deal with the main branch. Whatever changes
Yes,
you are going to employ here, they are directly going with there, right?
that's correct. Yeah,
You're
but
pushing directly
definitely
there.
some command will be there. I think this you try this get checkout and your branch name, right? Once you clone it,
Yeah. Yeah, actually I tried it only on the Visual Studio and this one. So yeah, this is a good one for RAG. Yeah, so I mean, I like this idea. So I was thinking of like using this collab for just cloning and all those stuff. So I was just thinking about that, like whether I can check out also. But yeah, I think you're right. We can do is like when we are git cloning, there we can check out it like locally as well, kind of instead of directly go using the main branch. Yep,
no,
we can try
I
it.
tried that. I tried that way,
I
but
mean, I didn't try it, so I'm not sure. So
no, no,
yeah.
no. Let me tell you, right? If you want to run these things on web browser, don't want to do coding on your local machine, right? There are multiple ways available. You come
No,
here
it's not
and
compulsory to do in the local machine because, like you said, that virtual memory and all of those stuff, it
correct.
will be very hard if you are not working from your office and you are not on the network and the you don't have that those sorts of the hardware and all those info.
Yeah, that's correct. But
Yes.
what I'm
So
trying to tell you here, there are other ways also. GitHub also provide a GitHub.dev option, right? Let me see if I'm logged in.
Uh,
I'm not logged into my account here. Otherwise,
mm,
once you click on a file, right, it will simply
mm,
give you option to open in GitHub Dev option, right? So it will open a URL. Let me log in first.
mm,
So, for example, if I go to my one of the previous repo, so here you see this is the option coming, right? GitHub Dev. Okay.
yeah.
So if you'll open it, right, it will open in a separate tab and it will give you all checking flexibility. You make your changes, you test it, you run it, you debug it,
Mm,
run it on the browser. Basically, it is integrated with Visual Studio environment itself on the web browser. You check in, you can
yeah.
check it directly from there. Those options are there. You can check
Okay.
it from there, you can check in from local, and all those flexibilities are there.
Okay.
Should I go to the
Thank you.
yeah, yeah, no problem.
Thank you.
Anything else, please? Okay, great. So let me go to the next step, right? So what I was saying, this is the right way to install your dependencies. We cannot, you will not run if you are using 10 Python libraries. You're not going to run your command pip install, do this, do that, do that, do that. It is not. It is not the right way. This is the right way. You create one requirements.txt file and you do pip install and give the file name. It will install all the dependencies. If dependencies are already installed, it will say requirement already satisfied and it will skip your step. Because I have been practicing on this Colab notebook multiple times, so that is it is saying I have this already installed on my machine. Okay. Now I'll talk on next point, right? For which we have basically connected, right? I explained in when I started I explained with this LLM example, right? I asked, what is my name? It did not know my name. But when I gave it certain context, this LLM, my name is this, I live in India. Then I asked for the question, where do I live? It know where do I live. It gave this answer. When I asked, what is my name? It gave my name also, right? So this is the same concept which is known as a RAG, right? RAG is nothing but you give your LLM certain context so that it can understand your further question. And whatever these LLMs are providing, they are only providing a content summarization, nothing more than that. They're not doing any extra calculation, right? Whatever you ask, they look into their dictionary and into their indexes wherever there are matching records they tell you, right? If you give certain context, then it will be able to answer your question in a more efficient way. So now let's come to the point for which we connected, right? Before I directly jump to the coding, let me explain you something. Like I prepared one document here. Let me open that. And guys, I would request you all like just to use that GitHub dev environment. It gives you very good flexibility to do the reverse engineering on your code. So what I did, right? Once you open your code with the GitHub Copilot here in the browser itself, I gave this code I gave this main.py file, and I said generate architecture diagram for it. You see, like it has written a code. I executed that code. It generated a file and saved the PNG diagram. This is very good these days, right? Every organization is almost providing these GitHub Copilot and other things, right? Leverage that. It is going to help you in terms of reverse engineering. If you don't know any complex code, it will help you to understand, give you the visual look and feel how to generate these documents, right? You can explore all those things. I'll simply focus on this document which I have prepared yesterday. So better let me open from my local machine. That will I will have more control. All right. All right. So now we are going to talk about one problem statement. Then we will discuss why are we using this Hugging Face. Okay, what is the purpose of going to the Hugging Face environment to solve one problem? Okay, I tried different ways. I went to different LLM sites. For example, I went to Llama, I went to OpenAI, I went to different Amazon related LLMs, right? But the challenge which I got from everywhere, everyone is asking for your credit card. I did not wanted to provide that. I don't know how that billing will be done. If someone has stolen my key, right, I will be charged for each and every token. So I did not wanted to go that route. uh, I did not thought like that is the right way to learn the things, right? Then I explored other things. How can I do that? I found this hugging interface, hugging face, right? This is a platform basically. You can create your login on Hugging Face, so it will give you a lot of flexibility over there. For example, let me see if there is any Hugging Face open on your machine. I think I closed it. You can go ahead and you can explore on your own, right? So Hugging Face is the way you have a GitHub, right? In the same way you have Hugging Face, you can create your account. You can log in your from your Gmail account, whatever. You will not have to create a separate login for that. And after that, what it will give you, right? It will give you the access on these LLMs, whatever you want to use. So you can pretty much every LLM is available over there. You will not require any separate. You will not have to pay for your testing purpose, your research purpose. Okay. So basically, I went there and I created a login over there. And after that, Hugging Face basically provides a lot of APIs available, which helps you to load any of the LLMs on your local machine. So what it will do, it will download, it will do installation, it will run installation, and it will do the installation on a local machine. And once it is done, then you can query to that LLM for any question, right? You can learn how these prompts are given to there, how you can enhance the prompts, how you can use a rack concept, all those things. That is something which is the next level of things, right? I'm just going to explain in this today's call how to start with that LLM coding, right? Gen AI, this is known as a Gen AI. How would you load a LLM on your local machine? How would you pass the input? How it would give you the output? How would you decode the output? And how would you show it on UI, right? So that is what the purpose of this particular exercise. And I already explained problem statement why I came on Hugging Face to have this free LLM integration. Okay, so I created one. So let me show you. Maybe that will be more better for you all. So if I search for Hugging Face, right? You go here. I am logged in from my email ID. This one. So if I'll go here, right, it will open my dashboard. So here there is the one option, access tokens. You come here. I remember by default it creates once you log into the system. But if you don't see, you can come here and create a new token. So this is the token which you will use before using any of this. Uh, in order to run these things, you will have to log in from your code to have access on those free LLMs that you have to practice on. Okay, so you come here, create it, and make sure you copy it, because I think after you create it, right, the moment you create it, after that you will not be able to have it, right? So better you create it, copy it, save it somewhere. And in order to save it, right, you can use your collab environment. Collab environment gives you this flexibility. You see here key option. You come here, you add your API key, give certain name, it will be masked and saved over here, and it will remain to your collab environment. You don't need to, for example, if I log in tomorrow, right, these keys will remain. This will not go away, and I can use this with multiple my notebooks, right? So follow this practice. Create a key, copy paste over here. So now you have a key, right? You got this particular key. So, what we were talking about, right? Let's talk about some of the we are using. Basically, if you see, you will find very good documentation on transformers. So just understand a little bit transformers. Transformers are why we are using transformers. Transformers are the common API which is built by Hugging Face. Basically, it is a interface over all LLMs, right? You tell transformer, I want to use this LLM internally how and what parameters it need to pass. You only need to provide the parameters, right? And internally it will invoke that LLM and it will give you the output. So that is the reason these transformer APIs are widely used, because you don't need to worry about underlying way, because each and every LLM may have different arguments calling these functions, right? So you will have difficulty learning all those things. For learning purpose, the transformer is a very good to start, and they are having certain APIs exposed by transformer, which is widely used in order to connect to LLM. Number one is a tokenizer. Number two is a auto model for casual LLM, right? So what it does, if you try to understand, right? I have given
Sir,
these step by.
sorry to interrupt, sir, but can you please repeat this transformer part again? Like,
Okay, transformer. Let's search on transformer. Let's see what it does basically, right?
yeah.
So if you go to Google and search for transformer. Okay, so here is the right place. Read this documentation, right? You see here, it is also showing you, right? Transformers is a API which is built by Hugging Face. It provides you flexibility to connect to different LLM exposed in the world. Okay, so
Mm.
this is just a interface given a common classes, common functions by which you give your model name. It will give the respective object, and you using those respective objects you go ahead and invoke the LLM, get the output, right? So this is basically for that particular purpose. Does that answer your question?
Yes, sir. Thank you.
Okay, and I would recommend to go with this Hugging Face docs, right? This is a very good place to start. And there are a lot of things I am also exploring, but I only focus on the things which is bare minimum required in order to implement the RAG. And RAG is something which is not you can implement in one go. First, you will have to connect to LLM. You will have to understand the context. Once you understand how how can you play with the context, right? Then RAG is the second step. So RAG is only going to provide you information at the runtime, the way I've given my name, right? So in one shot only, behind the scene, I will give two information to my LLM via code, right? So here, what I had to do, the example which I shown you, right? I asked my name, it did not know. But when I will do my with my code, right, I will give certain context. This is my name. I live in India. Then I'll ask question in which country I live, right? So where do I live, right? So it will be able to answer those questions, right? So in order to do all those things, these transformers are used. Okay. Any further questions?
So, sir, is it safe to say that transformers are just acting like a middleware between our code and models hosted on Hugging Face?
That's
It
right.
is it safe to say that, sir, right, sir?
Exactly.
Right.
Yeah.
Okay. And sir, one more question related to Hugging Face. So what I have seen is Hugging Face is like a model hub where we can explore data sets, explore different models, even some custom neural networks also we can find, and all kind of models we can find. But in the industry, let's say an organization is planning to have you create a custom application on LLMs for their business use case. Let's say a customer support agent. Let's say they want to build a customer support agent for their organization, and they have all the data. of their a conversation between the customer agent and the so like how so do they also use this Hugging Face middleware in their production, or is there any other way, like do they directly contact to the provider of LLMs, like if they are using Anthropic models, so do they directly contact Anthropic, or how does it work, like on
No,
organizational level?
they don't use a Hugging Face.
Hmm.
Hugging Face is mostly used by companies which are low budget or those kind of things, right? Every model provides its own libraries in Python. They provide a wrapper, and the way you call all those things, right, it is almost consistent and same way the way you invoke open AI, right? In the same way you will open in the same way you'll connect to your llama. So all those things are very pretty similar across the things, right? These are not too, there are not too much variations, but there are other things also on top of it. For example, like whenever we say that, right, we have I forgot that name. What is that used inside that? Give me a moment. I'll remind it.
The
Just
pipeline? No.
no, 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 no. Give me a moment. I'll find it. I'm not able to recall at this moment. I'm somewhere. It is on my GitHub repository. I'll find it. LangChain. Okay.
Sir, LangChain, yes.
LangChain is widely used. Basically,
Yeah,
LangChain gives you flexibility where
yeah.
for example, how would you provide a context, right? How would you provide your search query? Okay.
Mm,
So basically, and how would you remember all those context,
mm,
right? You search 20 things, right? How would you remember those 20 things? If you use this line chain, this provide all these APIs which remember all these sequences. You'll answer how many things I have asked in last 1 hour, right? Since I'm logged in.
yeah,
It keeps collecting all this information into memory. You can do all those things manually also, but why to put all those efforts, right? If LangChain framework is already there, then we can leverage that. But that is the second step. We'll go step by step.
sure, sir.
Okay. So here, what I was talking about, right? Let's see how would we connect to a learning LLM, which is available on this uh, Hugging Face. So, for example, you see here I am using Google Gamma, right? But there are a lot of this is not only one option. You can use GPT 4.5, lot of Llama, OpenAI, everything is available over there. You give the name and you call it, right? So that is how it works. So what the diagram that I was showing you, there are two main classes which is basically used over here. One is tokenizer, another is auto model for casual LLM. Okay, so basically what happens, and as a model name, you see here, whenever I'm there are few methods available from pre-trained model name, from pre-trained modeling. This is a common function which is available into auto tokenized class and auto model class casual LLM. Okay, so every model LLM, what it does, right? So if you understand this, let me give you little one, two, three, four, five, right? Then you will be able to correlate all those things in a very better way. So, for example, if I ask some query, okay, I'll explain this topic later. Context, question, all those things. We'll do that later. We'll not get into complexity at the first step. So I ask certain question. So whatever question I am asking, what it does, right? There is a tokenizer API available. What it does, whatever numeric things I'm asking, it will convert to the numbers, and these are nothing but vectors. How these LLMs are storing behind the scene data is not the plain text. Okay, there is a lot of things in the background, and I mean, I would say mastering all those things requires minimum 1 year, right? And someone also in our group said the same thing. I totally agree with that. There are a lot of things in the background. This machine learning is not from today. This Google was using for last I would say 10 years, very widely, right? This came into picture, this came into boom in this last 1 or 2 year, right? So now we started learning what is this, what is that, because they introduced those LLMs, and it found very intuitive. You ask any question, it knows everything, right? If I would say this is, I'm using this these LLMs for learning purpose, researching anything. Everything is not available on Google. You have to go to 20 places to find your answer. But here it is very interactive, right? So and like these LLMs, whatever are in the background, once you ask any question, it goes into the background. So what it does, right? Whatever you ask question, it basically tokenize your query. For example, I asked, my question is what is RAG, right? So every model has its own pattern of tokenizing thing, right? So due to that reason, we will have to load tokenizer from that particular model. Okay. For example, the given example which I have prepared, I am using Google Gamma. So I'll go to Google Gamma tokenizer, because if I'll use any other tokenizer, right? Other tokenizer will not understand. These tokens are basically stored in these LLMs databases, vector databases, and whenever you ask something, right, they go to their vector databases and they do the similarity search on your input on numbers. That is this number, right? You ask what is RAG, it converted into this input token, right? So basically this input token is converted, and these things are, they whatever you ask, right? You basically, I asked this thing, they went to their vector database, they searched for this, and they found this is the vector index for that particular search for these three words. And this is very large, like you'll find very big string. It was not possible to put everything, but in demo I'll show you like how these things comes over there. So it gave a similarity index for this particular thing, right? Sometimes I can ask something different, right? And one word can have different meaning also, right? So whatever will be the most matching word, and it does the similarity search also, right? So that is the beauty of that vector database. Vector database. If you compare, if you say why we started using vector database, because your database is SQL, Oracle, right? They do the exact query, they do the like search, right? But they do not do the semantic search. Semantic search meaning to say, um, uh, this is very cold today, right? I need sweater, I need jacket, right? So these two things are quite matching, right? I am feeling cold. I need jacket, right? So these things are very semantic things, right? If take an example, um, like LLM in their database, they does not have I'm feeling too cold, right? Then they will give me the answer. I need jacket. You need jacket, right? So they will do the similarity search, right? And some take an example. If you're going to build uh, certain knowledge engine for your organization, you will face this kind of problem too much, right? For example, what is leave policy, right? Or work from home policy or remote policy. Someone search for work from home policy, you will say I do not have anything, but whereas in your database you already have remote work policy, right? So RAG, this vector database are smart enough. They understand what you are trying to ask. They do not go with the exact keyword searching. Vector databases stores the indexes of each and every word, and whatever is the nearest one, right? They go ahead and do the things. Am I audible, guys?
Yes, sir. Yes, sir.
Okay. Let me pause. If there are any question.
Yes, sir. I have a question. Sorry, I'm missing the question right now. Yeah, you said vector database are smart enough to do the semantic search. So what I understand about the databases are like they are like used to store our data in form of vectors so that whenever LLM is doing the semantic search, it can retrieve the information from that vector database. So Is my understanding right, or the semantic search is done by the vector database itself, or is it by the algorithm that
No, what happens, right?
yeah.
For example, you have certain data set. Take an example, your policy document. Okay.
Okay.
So you will have to store the first step in order to provide the semantic search would be you will have to store all policy documents in your vector database. The
Right.
moment you store, it will generate certain hard coded indexes against your text.
Correct.
You're with me? Okay. So that
Correct.
is going to the first step. And then if in future someone will ask and query that particular thing, right, then it will be faster. It will go and find the similar matching numbers. It will return back and you will decode those numbers to the text, and whatever numbers it gave, right, you will pass it to
Hmm.
your uh, uh, based on those numbers you will convert. It will give you the similar matching text also, right? You will take
Right.
the text and you will convert it to the respective model tokenizer. Then it will you will pass it to the LLM things, right? So your vector database indexes and LLM vector database indexes will not match because those are two different databases, right? So you'll have to find those related numbers, convert back, and then pass it to the LLM, tokenize it, give it to that, then it will give you back. Then you ask the same question to your model, right? Then model will give you output. Then you decode your output and show it on UI. Show it on that is going to be your final output. So if I say here, right, the first step is going to be login to your Hugging Face. It will give you access on these APIs. And after that, your step one is whatever prompt you are getting, you tokenize it. You got certain token in this format. It comes in the form of tuples. These are numbers. You simply pass these numbers to your model for protection. It will take these numbers. It will give you certain output. Output will again will be in the tokenized format. You'll find the tokenized output. You decode the tokenized output from this auto tokenizer API has a method which is known as the decode output. Method. You pass your outputs. Basically, it will decode your output and show the matching record as a output. So this is what is happening in the background, and this torch is coming, right. It helps basically to switch between GPU and CPU. So that is the reason these torch APIs are used, basically dynamically switching between. If your code should be smart enough to switch between GPU and CPU, right?
Hmm.
So this particular torch basically helps you your code to understand whether when to use what.
Okay.
Okay,
Yeah.
is that clear?
But sir, my question was related to that vector database. Uh, uh, like in a traditional database, let's say talk about in the database that we use in our organization, we have something called indexing, database indexing that we use to retrieve information that enhances the query performances, right? In let's say I just want to connect this analogy with the vector database. So let's say LLM wants, let's say you have asked this question to your LLM, that what is my name, and that information is residing inside the or the LLM is supposed to get the answer from the vector store, vector database. So that semantic search that you were saying, so this question is directly like can be done with the indexing. I can understand like the question can be directly get from the vector store. But let's say if it has to done it has to let's say let's let's say I want to customize an LLM for a fitness app. So I want, let's say I want to know whether, according to my and stamina and endurance and my fitness level, how much push-up I should start with, or like what should be the routine for my workout, and that information I have provided inside the vector store. Let's assume everything is set up accordingly. I just want to understand about the semantic part that you have mentioned. that the vector database will do the semantic search. Uh, uh, so like that's where I'm feeling I'm getting this contradiction of my understanding, because what I understand is like it is basically a database for LLM. So uh, is it the database for the LLM, or the semantic search part is done by the LLM, or the vector store? That is my core question.
Semantic search is done by vector data store.
Vector store only.
So
Okay.
that is the reason it is different than your Oracle database,
Okay.
Oracle SQL Server. SQL Server does not store any in their memory, right? In their framework, it does not have anything related to. If I have asked question, if I have in my vector database, something is stored as a dog is a good animal, right? So
Yeah.
if I ask question about puppy, right? It does not have puppy in vector database, right? But it will give you the matching numbers. Like I do have this dog example, right? it
Hmm.
is it is going to give you the closer result, and there is a concept known as the vector distance. Okay.
Okay.
So
Hmm.
whenever you store anything in vector database, it stores with a vector distance also. I also have done POCs on this. I have
Hmm.
working example. I'll explain everything, but in one session, everything is not going to be possible. But I
Hmm.
have all those things here. I did POC sometimes back.
Hmm. Hmm.
And I have those things ready to demo, right? So I have explored these things, and I have answers on all those questions which you are asking. I'll be happy to answer all those things. So what I observed, right? I created a vector database. I went to Redis cloud and created a vector database. Again, I was exploring fleet options. I found that, right, and I stored a certain 5, 10 data set over there, and I did a semantic search. It gave me a very perfect answer. So what it does, right, whenever you query to that, it use KNN algorithm over there.
Hmm.
K means search algorithm.
Hmm.
So K
Hmm.
means search algorithm basically behind the scene, and these are vector databases. Why we use that? If we have Oracle databases, because Oracle database is a dumb database. Whatever you'll ask, it will give you that answer. These
Hmm.
vector databases are popular. These are known as AI databases because of they understand your semantic meaning. They
Hmm.
whatever. Take an example. You saved certain text. It converted to certain number. If you'll ask anything related to that, right?
Hmm.
Once your search result will come, it will even if you do not have that keyword in their vector store, it will find the matching rows from the database. You getting? For example, like example that I took, work from home or remote policy, right? So if work
Hmm.
from home is not there in vector database, it will find the answer from remote policy, remote work policy. So it is that
Hmm.
smart. Okay. We'll go that step by step. Let's finish this particular part.
Sure,
Anyone
sure, sure.
else? Any further questions, please? I just wanted to make sure I'm not going too much in depth at the first moment, making sure you're able to digest, right? Should I go to the next step? Okay, all right. Seems like we're good to go, right? So now, what I did, right, so far. Now, here, if you see, right, I'm going to load the main method, main file from my Python program. So my main Python program is doing what? It is basically connecting to this particular Google Gamma LLM. What it will do, right? It will connect to this. It will connect to the token API, which I was telling here in my example. This one, auto tokenizer. It will whatever input I will be passing, right? For example, I'm asking going to ask what is RAT, right? So it will take my input. It will convert to the numbers, and it will pass to with the help of these token APIs, right? It will convert, and these all things are over here, right? If you go and see what this code is doing, first I'll explain the code because I'm invoking this code from my notebook, so it's important for you to understand what is happening in the background. So if you see here, right, what it is doing, basically, first step, what it does, it basically, I have this environment file here, right? I added these entries over here. So if I'll run from my local, it will load it from here. So this is like the way you load your environment variables from the respective environment. But while I'm calling from that place, right, I'm setting these values, these environment variables from my that in Google Colab, right? I'll invoke it, and it will automatically, that value will be available into this environment variable, and it will come. It will have these values decoded over here, and it will further use it for processing. So if you see here, right, what I'm doing here, basically, I in my example, I told two classes, right, which was auto tokenizer and auto model for casual LLM. My model name is this Google Gamma, which I will which I'll be passing from my this guy, this collab from there. Or if I'll run from local, I'll have this thing, right? So after that, what it's doing, it is this is the PyTorch example which I was telling, right? Yeah. If it is a GPU, it will use CUDA. If you do not have GPU on your machine, or if you run it from your local machine, and if your local machine does not have, if it does not have a GPU, right, it will simply use CPU. Okay. So what we are doing, we are creating the object of model and tokenizer, which I explained in this example, model and tokenizer. And what we are doing, we are taking the input. This is my input, and I'm passing the context with my input, right? I gave certain context. Hugging Face provides an interface to connect with LLM, right? So that means I gave my model to understand the context. Then I ask what is Hugging Face. If we do not give this, right, then LLM will get confused. Hugging Face, what is Hugging Face? It will say hugging and face. It is not possible, right? So it understands a different emotion if you do not give these particular things, right? Hugging face. So that is reason this context is important. I set this context, and I finally prepared my LLM prompt. So there is a syntax by which you have to feed your context and give your query. So this is a pattern which, like by which you can set your context, what you are asking for, give certain context to your uh, LLM, and give your query. So you gave your context, you gave your query, and to your curiosity, right? This value which I'm talking about, this is also a rag, right? Because you are
Hmm.
setting the context. Setting the context is a rag. From where you will store from file system, you will store from vector database, you will store from some hard-coded JSON file. That is up to you. That you can decide at the runtime, right? What you will do. But
Correct.
RAG is the same concept, right? You given certain similar meaningful context is providing meaningful context to your LLM is a RAG, right? Retrieve augmented generation thing. So here you found this, like you gave this context. You found again you gave this particular LLM prompt input to the tokenizer. Tokenizer converted it to the vectors, and you are passing the same vector to your model or generate method, and it gave you output in a uh, encoded format, and you decoded that output, which you got it from there with this decode method, which is a part of auto tokenizer API, right, which I was explaining over there. You found this output, you shown this output on UI, and you're done, right? So that is what it does behind the scene when you are dealing with these kind of things. I'll show you the running example. And here, the first thing, right, I tried doing this, and I converted this thing, broken down everything to the function. So this is my one function. If you see at the what all my document is saying, this code is also saying the same. What I did, I prepared the prompt. I'm taking prompt as an input. So my Google Colab will pass this prompt. I'll take that input. I'll pass to my tokenizer method. Tokenizer method is what it is doing. It is taking the prompt and giving me the tokenized output. I'll find the tokens. I'll pass the same token to the my model output here. This is model output function. So model output function is basically doing model or generate, calling model or generate function, where I'm passing my same input tokens, and I'll get certain outputs. Whatever output I'll get, I'll decode that output. I have written another function as a decode output. So it is using tokenizer.decode function. I'm passing my whatever output I got, I passed first parameter of that, first index of that, and I got that content, and I simply written that content, and this content will be printed on my Google Colab. So let's just go to the next step. Invoke this code from Google Colab. And why I'm doing this from Google Colab, I already explained. There are constraint to the memory, there are constraint to virtual memory and other things, right? So Google Colab is the best place to execute these things. Should I go ahead? Any questions? I would like to take a pause. Are we good, guys?
Not a question, but sir, really good appreciation for the RAG reference from this context. I really like that reference.
Yeah, thank
Just a
you.
feedback. Yes, sir. Thank you.
Yeah. So now what I'm going to do, right? I'm going to load this model, this LLM locally, and you will see like once it will execute, right? It will try to, if it will execute this code on your local machine, what it will do, right? It will try to uh, add those things to your app data folder, and it is quite good size. Like sometimes it is, I think this model is the shortest one. It takes 2 GB of the space, so it will start doing the same thing. But while downloading, this command will fail on your local machine because of the virtual memory constraint, right? There, it basically there are certain code written into this library, right? Whenever you're trying to load certain model on your certain local machine, so it has certain memory requirements. So those memory requirements are not satisfied from your machine if you do not have GPU and other things, right? So that is the reason we are doing this thing. So here, what it is doing currently, it is basically loading all the required models and tokenizer. If you see here, right, what it is doing, basically it is loading your gamma model. So this is in progress. Once it loads your gamma model, then it will load the tokenizer APIs. And this once this tokenizer API is done, right, then and then other code will get executed, right? After that, I have written code in the code which I was explaining. It will prepare the prompt, convert it to the input vectors. Those vectors will be passed to the model. Model will generate the output, and will decode the output, and will get the answer. Okay, so at this moment it is just loading tokenizer and dependencies on your machine. So my machine here is Google Colab. So somewhere it is going at this place where I do not have any visibility, where it loads and where it does not load, right? It might be adding here under config or this particular somewhere, someplace. So you see here it loaded this tokenizer model,
So
and
on the
here is the
disk,
right.
on the disk, right, sir? It is loading on the disk, right? Right, sir.
No, it is loading on Colab server, not on disk.
Collapse.
Colab server.
Collapse servers disk. So, like we have, we got 81 GB of disk memory, right, sir?
Hmm.
Yeah.
So it uses the same one, whatever you have.
Yeah. Yeah.
Okay.
Yes.
So currently you see, I asked this question and I gave this context. So it converted, and I passed this whole is known as a prompt, right? This and this one. So I wrapped my prompt with this. So it went to Tokenizer API. Tokenizer API converted my this input context and question to these vectors, right? And the next step is still getting executed. This out input which I got from that Tokenizer API, you see here this model is generated right now, right? So the way pattern I gave, right, what pattern I gave, LLM generated response based on the following question, this was the pattern I gave, and I left the placeholder for answer, right? So wherever I left the placeholder for answer, it will fit in my answer over here. And sometimes it gives you more than one answer, right? The way you see in the your LLMs, what it does, it gives you one answer, it gives you multiple answer, you have to choose. So these are the things that we'll have to explore. And also, like, line chain is the best wrapper which is used in industry to deal with these unstructured data models, right? So here we found the output, right? And again, what I'm going to do now, my model is loaded, right? If you see here, what I did, right? This main, once this main will get executed, right? the way I have written the code, right, my model object will get prepared. Okay. So what I can do as a next step, so here you see, right, I had created one generate content method. Okay, so my main I have already loaded it over there. So under main, that means whatever variables I have, that means model equal to model object is already there into my memory, right? So what I can do here, I can simply ये चिल्ला रही है बिना बात के मैं तो अपना काम कर रहा हूँ मुझे कावल निकालो चिल्ला रही है चलो चलो so I'll directly go to this step. Uh, that below step was just a placeholder. I tried multiple things, but this is something which will help you to understand. So I written this main I have imported here, this first place, import main. So my main has that particular things, and it will also maintain the state, right? So I asked main dot generate content, and I gave the LLM prompt, which contains my context and query. It will go there, and internally it will call all these methods, right, which I have written these private methods here. This it will tokenize, it will pass tokenized input to the output model. Basically it will pass to the generate model, it will give the output, I will decode that output, and I will show that on the screen. So all those things I have clubbed into one function. I'm simply taking feed as a prompt is going, and internally behind the scene it is doing all the things that is needed. So let's just execute it. So you see here, like it executed till this moment, it generated the input, right? So what here I am saying, right? I gave this context. You see here, Hugging Face provides an interface to connect with the link, right? So now I'm asking what is my name, right? So because I gave the context of Hugging Face, then it will say your name is Hugging Face, right? My name is Hugging Face, something like that. We should expect that similar kind of answer because we tweak this output based on the input, right? And these are the challenges, right? Due to that reason, we need to come to collab. You see how much time it is taking because it requires a lot of processing memory in the background, which is not possible uh, on your local machines, basically. So you see here, it is saying Hugging Face also provides an interface to connect with AI. Okay, so it understood something similar what I'm asking this, and there are certain challenges also with these particular things, right? If you do not give the right context, your answer may not be right, right? So for example, you are building a rag and you're not giving it the right context, your vector database query is not correct, you are feeding something wrong input, right? It will start giving you the wrong answers. The way you will give the context, the way it will give you the answer, right? So it is very important, like our search pattern and all other things should be very efficient, right? And in terms of if you say rag, right, how would you fit in rag? Rag is nothing but this array, you populate it from some similar search. Use vector databases, Redis vector databases, use Elastic databases, use any other database, right? Or use any other mechanism, right? Where you can do it. You necessarily do not need to go to every time to your vector databases. If you have any other faster mechanism where you can quickly search the semantic meaning of your text, which you want to feed it to LLM, you go it that way. Hey guys, that's all I had. Let me
Hmm.
know if there are any questions on this. लेकिन आप काम कर रहे हो तो मैं कहूँगा इसे select हो गया। आपने मुझसे कहा था कि एग्जाम हुआ है। डांस करने में तो गिर जाओगी पागल। क्या गिरूंगी? नहीं, बता दो। ठीक है, रुके रहना। मैं भी
Shahnawaz, you are not audible if you are speaking. Yeah. Parminder sir, that is a very detailed session. Matlab, like I really like the yeah. Yes, sir.
Yeah, great man. A lot of things to explore. Please let me know if any one of you is interested in exploring these things. Right, there are a lot of things in my mind. But if someone, I'll get it. Someone right who can work in parallel. That in that way, we can succeed more. Right. For example, I'm exploring something. We have some other areas to explore. Right. Another person can explore those, and we can come collectively. Right. I
Correct.
find this. I found that. Right. Then we'll be able to connect the dots,
Correct.
and we'll
Correct.
be
Correct.
very near to the industry and just standard the way they are living. Hey Shanwas.
Correct, sir. So, like currently, I'm also reading LangChain documentation, sir. I'm trying for a project that I'm trying to make. For that purpose, I'm researching about LangChain and this agentic AI design patterns also, like how to create this agents workflow and all everything. So that's why when you said LangChain, so I'm very interested in like researching about LangChain framework because if we really want to deploy an application of agentic AI, the LangChain is the right framework for the as per the industry standards, right, sir?
Yeah, definitely. LangChain is widely used. Basically, it provides you flexibility to deal with your interaction and context, right?
Hmm.
So that is something. Otherwise, you'll have to do a lot of coding.
Correct. They
Yeah,
they they
definitely. I'll.
also they also have like a lang serve and lang graph for creating the graph of the agents and the lang serve for the deployment part and there's lang smith also. So the whole ecosystem they provide to develop an LLM application. So
Yeah, that's correct. So Himanshu, next time we will expect from you read
I'll try.
LangChain and explain to us.
Like don't no worries, sir. Like whatever I will read about LangChain, I will prepare a documentation and will share with you like what I understand and what questions I came up with in the last and what questions I answered and everything. And yeah, so I will share with you and with everyone also.
Yeah, definitely. Great.
Thank you, sir. Thanks for a wonderful session. The
Hey
session is
man.
great and the session is going on.
We truly utilized our time.
No, man. I mean, we all have this level of capability in us. You just understand your capability
Yes.
and come up with certain things, right? That will be really helpful for everyone. That will, for example, today we are at here, right? But we will definitely reach at the more maturity level if
Yes,
these
sir.
kind of small things start coming from each one of you, right? For example, Himanshu is exploring Lang chain, right? And maybe Satyam can explore something else. Anyone can take another topic, right? So, because I mean, understanding till the industry level, it takes a lot in the background, right? This is something which I have been exploring from 1 month, right?
Yes,
After
sir.
that, I had multiple challenges in connecting to LLM. Everyone is asking for credit card, doing research, these, that, right? So it takes a lot, um, and if we one of us take one area, right, and do certain hands-on POC and share with each other, right, that is going to be win for us. I'll share this whole repository to you. You can go ahead, clone. I mean, download on your local machine for any testing purpose. Right?
Thank you, sir. So, Himanshu, please to include for all the future sessions like that. Yes.
Okay, I'll just stop the recording, sir. And also, I want your permission to, add your GitHub account onto this description for this video, right? Because people would like to go to your GitHub profile right after this session if
Yeah,
they.
yeah, sure, no problem. Man. I made it public, so just check it if it is accessible. If not, I'll make it public.
Sure,
There's
sure.
nothing confidential as such. It's just a learning purpose, right? So it's fine.
Okay.
Yes, sir. It's accessible.